Now today student will start with the compound microscope. Compound microscope. तो पहला पॉइंट आप लिखिए, it is consist of two convex lenses. It is consist of two convex lenses called objective lens and eyepiece lens. Called objective lens and eyepiece lens. Objective lens and EP eyepiece lens. Focal length of both objective lens and EP, that is eyepiece lens, are small, and FO is greater than FE. FO minus FE, difference is small. एग्जाम्पल हम ले सकते हैं, FO is 5 centimeter, FE is 2 centimeter, and this is all done for eye magnifying power. Eye magnifying power. तीसरा पॉइंट आप लिखिए, it is used to view micro objects, very small in size. Micro objects. ये इसके कुछ इंपॉर्टेंट पॉइंट्स होते हैं. तो आगे बढ़ते हैं. अब हम डिफाइन करेंगे इसकी मैग्नीफाइंग पावर को. Now we'll define its magnifying power. Definition of magnifying power. M equal to beta upon alpha. Beta angle subtended by the object at the eye. Angle subtended by the final image. By the final image. So we should write by the final image. At the eye. ये क्लियर हो गया। अब यहाँ अल्फा का थोड़ा डेफिनेशन चेंज होता है। एंगल, इसको ध्यान दीजिएगा, सबटेंडेड by the object at the eye when object is at a least distance of distinct vision from the eye। ये देखिए यहाँ डेफिनेशन चेंज होगी। सपोज करिए ये ऑब्जेक्ट है, तो अल्फा किस एंगल को एज्यूम करेंगे? अल्फा तभी होगा जब ऑब्जेक्ट आई से कितने डिस्टेंस पे होगा? डी डिस्टेंस पर होगा। देन वी विल कॉल इट अल्फा। ये हम एक इक्वेशन बनाते हैं, इसको आगे हम डेरिवेशन में यूज करेंगे। tan अल्फा इक्वल टू प्लस ए बी अपॉन माइनस डी, लेफ्ट में है। यहाँ से हम tan अल्फा को कैलकुलेट करेंगे। ये आप लोगों ने नोट कर लिया। तो यहाँ अल्फा का ये डेफिनेशन हमें ध्यान देना है। अब देखिए सबसे इम्पोर्टेंट पार्ट डेरिवेशन का, रे डायग्राम। This is our objective lens. Now consider a micro object AB which is kept in front of objective lens. So objective lens forms the image of this micro object. Let the image is A dash B dash. Now this is called first image. Now what eyepiece EP lens does? You can refer your books for the diagram. अब देखिए, मान लीजिए, so this image work as an object for the eyepiece lens. Please look at the diagram, how I have formed it. This is the final image. and here is your eye. तो यहाँ हमें पता चला। अब देखिए, थोड़ा अब हम मार्किंग करेंगे। UO, object distance for objective lens. This is VO. This is UE. Because first image work as an object for eyepiece lens. देखिए, first image is real and inverted. Final image is virtual. क्योंकि light rays have been extended back in back direction. Virtual and inverted. UO, object distance for objective lens. VO, image distance for O lens, objective lens. UE, object distance for EP, eyepiece lens. And suppose किया कि final image कहाँ बनी है? Wait a minute. Let us suppose that final image is formed at least distance of distant vision from the eye. So L is here, length of tube. Clearly, length of tube is VO plus UE, and this angle is beta. So draw the diagram. Okay, so we are proceeding for the next slide. अब हम मैग्निफिकेशन फॉर्मूला मैग्नीफाइंग पावर के फॉर्मूले को हम डिराइव करेंगे. Now we will derive the formula for magnifying power. देखिए, M is given by beta upon alpha. Since alpha and beta are small angles, so we can write अब देखिए आप ये था आपका ट्रायंगल ए डैश बी डैश ई this was alpha or beta and this distance is u and just now we have done AB so by using these triangles we'll find the value of tan beta. Now tan beta is minus A dash B dash upon minus UE. Tan alpha will be plus AB upon minus D. So minus A dash B dash upon AB into D by UE. अब देखिए A dash B dash height of image for O lens. AB height of object for O lens. D थोड़ा पिछली स्लाइड पे जाएंगे देखिए D क्या है D is the distance of image which is formed by eyepiece lens because you know that A dash B dash work as an object for E lens. So E lens forms the image of A dash B dash as A double dash B double dash at a distance D from it. So for E lens, UE is the object distance. For E lens, UE is the object distance and D is the image distance. D is the image distance. तो ये देखिए ये तो अब हम यहाँ पे D को डिफाइन तो कर ही सकते हैं image distance for EP lens and UE is the object distance for EP lens. तो देखिए इस बात को आप अच्छे से समझिए तो यहाँ पर हम इस फॉर्मूले को कैसे लिख सकते हैं m इक्वल टू मैग्निफिकेशन ऑफ ऑब्जेक्टिव लेंस मल्टीप्लाइड बाय मैग्निफिकेशन ऑफ eyepiece lens. So note it down this. And you can put a minus sign पर minus sign का सिर्फ एक ही मीनिंग होता है that final image is Final image is inverted, nothing else, nothing very special meaning it has got. So in compound microscope, so far we are using how many lenses? Two lenses, O lens and E lens. So what formula we have derived for the magnification? MO into ME. If you are using the three lenses, then the formula for magnification will be M1 into M2 into M3. So I am moving to the next slide. तो ये हमारा हो गया डेरिवेशन, ठीक है। तो m is equal to minus mo into me. अब हम इसको लिख सकते हैं माइनस vo अपॉन uo into d upon ue, and we have already derived the length of vo plus ue. Case 1, when final image is formed at least distance of distinct vision from the eye using lens formula for EP lens ये देखिए EP लेंस का हम लेंस फॉर्मूला, ये ऑब्जेक्ट हो गया और ये हो गया, दिस इज ऑब्जेक्ट एंड दिस इज इमेज. Plus Fe because it is a convex lens, minus D left. So 1 upon Fe plus 1 upon D equal to 1 by U. अब हम इस फॉर्मूले को ऐसा भी लिख सकते हैं into D into 1 upon U. So magnification will become फिर आप D को अंदर मल्टीप्लाई कर दीजिए, we'll get the answer. So multiply D inside the bracket. So that is the part of derivation of magnifying power. So now we'll multiply D inside the bracket, and this is Fe plus D, it should be plus. So we'll get it, है ना, अब हमें मिल जाएगा, अब हम D को अंदर मल्टीप्लाई करेंगे. So this is the magnifying power formula. When image is formed at least distance of distance. Furthermore, we know that 1 upon Fe plus 1 upon D is 1 upon U. Take the LCM, reverse it. So UE can be written as dFE upon D plus Fe. So the length of tube in this case will be VO plus UE. Modulus. You can put modulus over here also. If you'll see the records of previous year examination, you can go through the last 10 years paper of physics. 5 marks question from ray optics. Most of the times you will find either astronomical telescope or compound microscope. So these are very important application of refraction through lens. Now we will move to the next second case. When final image is formed at infinity using the lens formula for EP lens means eyepiece lens. Equal to 1 upon UE, so UE will be Fe. So magnifying power and length of tube is VO plus UE, VO plus Fe. So we have noted down. अब देखिए सबसे इम्पोर्टेंट बात यह है फॉर्मूला याद रखना है. देखिए मैं यहाँ कुछ लिख रहा हूँ. I'm writing here. Magnifying power is VO upon UO into D upon UE, and length of tube. Just see this. VO plus UE. So the value of UE can be calculated if we are told whether the image is formed at infinity or least distance of distribution. But without VO and UO, you cannot calculate the magnifying power. So let's do some questions taken from your exams. UE equal to, this should be FE. Okay. देखो, अब let's start. Question 1. The focal length of the objective and eyepiece lens of a compound microscope taken from your examination of a microscope compound microscope are 4 centimeter and 6 centimeter respectively. If an object is placed if an object is placed at a distance of 6 centimeter from the objective from the objective, find the magnifying power of compound microscope. If final image is formed at infinity. Now we will solve this question. Two types of questions are very important. This is one of them. Given least distance of distinct vision is 25 centimeter. So note it down. We will solve this question in the next slide. In previous class, I solved one numerical for telescope. It was so simple. यहाँ थोड़ा numerical typical हो जाएगा. So focal length objective 4 and eyepiece 6, or object is placed at a distance of 6 centimeter from the objective. Okay, so we are moving to the next slide. And we know that this is VO. तो ये तो हमें निकालना पड़ेगा. UO is given as -6 centimeter. FO is convex lens plus 4 centimeter. Now using the lens formula, 1 upon F equal to 1 upon V minus 1 upon U plus 4. This is VO. We don't know. We need to find it out. And you know that this is the objective lens. So now we have calculated VO as 12 centimeter. VO कितना आ गया? 12 centimeter आ गया. Use distance of dressing vision is given. So this is objective lens. ठीक है. तो अब हमने ये VO था और ये VO था. हमने VO को क्या कर लिया? कैलकुलेट कर लिया. Since the final image is formed at infinity, so UE will be FE plus 6, that is 6 centimeter. I think it is given as 6 centimeter. Yes. Now magnifying power. UO is 6, D is 25 upon 6. So it is minus 50 by 6. So you can write the 25 by 3. That's all. So this way you can solve this question. There are two or three types of question. This is one. तो अब हम ठीक है, तो अब हम आगे बढ़ते हैं. We'll do one question from your previous paper. The focal length of objective and eyepiece lens of compound microscopes are respectively 5 centimeter and sorry, not 5. Wait a minute. तो सबसे पहले हमें ऑब्जेक्टिव की फोकल लेंथ लिखनी है. Now we have to write down the focal length of objective. 1 centimeter and 5 centimeter respectively. And the length of tube is 20 centimeter. Tough question है. Calculate the magnifying power of telescope. B is given as 25 centimeter. Wait a minute. Let me draw it clearly. This is AB, this is A dash B dash, and this is your eyepiece lens. This is UO, this is VO, and you know that this is UE. अब हमें given है length of tube. Now we are given the length of tube. How much? 20 centimeter. ध्यान दीजिएगा. So we are given this distance as 20 centimeter. So we are given VO plus UE is 20. Just look at the diagram. FO 1 centimeter. FE is how much? 5 centimeter. And since final image is formed at infinity, so UE should be equal to FE. That is 5. इसको आप नोट कर लीजिए. तो यहाँ पर हम UE की वैल्यू को पुट कर देंगे. Now we will substitute the value of UE over here. तो UE का वैल्यू है 5. तो हमें VO मिल जाएगा 15. VO मिल जाएगा 15. So let's move to the next slide. Using the length formula, प्रैक्टिस करिएगा आप इन क्वेश्चंस for objective lens. This is very important. Objective lens focal length plus 1. We have just calculated plus 15. So UO will be minus 15 by 14. M equal to VO by UO into D by UE. 15 minus 15 by 4, 25, 5, it will cancel 5 times. This will also cancel. So the magnifying power will be 14 will go up. Wait a minute. इमेज, गलती से भी आप इसे रियल मत लिख देना, वर्चुअल बनती है। इन्वर्टेड इमेजेस, इसको प्रैक्टिस करिए इस तरह के क्वेश्चंस को। यू विल फाइंड सच क्वेश्चन इन योर बुक्स आल्सो। इस तरह से आप इन्हें सॉल्व कर सकते हैं। इसका मतलब मैग्निफिकेशन 70 है, इसका मतलब वो ऑब्जेक्ट साइज को 70 टाइम्स इंक्रीज कर देता है। ओके, अब देखिए कुछ सिंबल्स के बारे में हम बात करते हैं। तो ये तो हमारा आंसर आ गया, कितना आ गया, -70। So let me repeat certain points for you. अब देखिए, एक रे डायग्राम का स्कीम पर बात करते हैं। O E first image, final image, VO object distance, and this here is the object. So it is UO, it is UE, magnifying power MO into ME, magnifying power VO by UO into D by UE, length of tube VO plus UE. In case 1, जब इमेज लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन पे बनती है, U equal to DFE upon D plus FE. Case 2, when image is formed at infinity, U equal to FE. So this is A dash, B dash, A double dash, B double dash, A, B. MO, magnification produced by O lens, objective lens, ME by E lens, EP lens, magnification produced by EP lens. इतने फॉर्मूले आपको ये सब मालूम होने चाहिए, इम्पोर्टेंट है। Okay, so note it down. अब हम कुछ क्वेश्चन है आप लोगों के लिए लिख देते हैं। देखिए अब आप सिंबल समझिए। क्वेश्चन नंबर 1, M is 20, M is 5, find MO. Short answer question. Question number 2, final image is formed at least distance of distinct vision. FO 2 centimeter, FE 6 centimeter, UO 6 centimeter. Find magnifying power, length of tube. Final image is at infinity. Find UO, VO, MO, ME, and M. ME stands for magnifying power of eyepiece lens. MO stands for magnifying power of O lens. O lens का मतलब हो गया हमारा ऑब्जेक्टिव लेंस. So we have written it. So I'm putting an end to it.